This is the homework helper for Chapter 3, Section 8 in the workbook, which is entitled Adding and Subtracting Mixed Numbers. Okay, so I'm starting off here with some questions that are a little bit more difficult than the starter questions in each section. And by that I mean 1 and 2 and 10 and 11 and 12, because those questions have already done a little bit of the grunt work for us because they already have a common denominator. These questions that you see on the screen right now do not. So I will show you where you would pick up with those questions in just a minute. But let's begin with number 5. Notice 1 through 9, you're all going to approach these similarly, have the same directions, and we're supposed to add and to write the answer in simplest form. Now, because we're still adding fractions, even though they're actually mixed numbers, they have fraction parts, we'd have to do common denominators again. So taking a look at question 5, we've got denominators there of 10 and 5, and that's where I'm going to approach first, finding a common denominator. And of course that's 10. I don't think you need me to write that down. 10 would start at 10, 5 would go 5, 10. The least common multiple match is at 10, which changes into the least common denominator. So this fraction on the left isn't going to change. But as far as the one on the right goes, I'm going to have to double it. When I say double, I mean multiply the top and the bottom by 2, which is how I get 4/10, and that's my common denominator. Now this is where you'll start now on questions 1 and 2, for instance, because now we have the common denominator. What you want to do here to approach these problems is work in parts. Add the whole numbers together, and then add the fractions together. So I've got 6 and 1, which is 7, and 9/10 and 4/10, which makes 13/10. And right there you should see that you've done some good work, but you have a problem. You have an improper fraction inside of a mixed number, which simply cannot be. So what you're going to have to do now is rename this guy as its own mixed number and recombine. 13/10, as you know from our work earlier this year, changes into 1 and 3/10. 10 goes into 13 one time, which is where that guy came from. Would leave me a remainder of 3 if I divided, which is where that came from, and the denominator would stay the same. So this is really the same as 7 plus 1 and 3/10, and that's going to give me 8 and 3/10 as a final answer. Now, let's say that's bothersome though, which it might be. It may be a little confusing, a little hairy, whatever you want to say. You do have another option. Back up here where we got to the common denominator step, you could, if you wanted to, change these both into improper fractions and go from there. That is not bad. That is actually an approach that might work better for some of you depending on how skillful you are with this technique. Here, this is going to change into 69/10 as an improper fraction. How did I do that? I did 10 times 6, which is 60, plus 9, which is 69, and remember the denominator stays the same. And this other one is going to change into 14/10. 10 times 1 is 10, plus 4 is 14, denominators stay the same. And that's going to be 83/10. Now, here is the one little hiccup with that. Mathematicians are kind of an odd group, and generally, unless it's impossible, or they give you a direction to the contrary, they want their answers to be like the question. And by that I mean, since we had mixed numbers, they want an answer that's a mixed number. So the one little hiccup here is you're going to have to bring this back to being a mixed number now. 10 goes into 83 8 times, would leave a remainder of 3, and the denominator stays 10. And as you can see, we've matched our answer from the other technique. It does not matter which route you employ here, as long as you come up with the correct answer. Okay, let's look at 14. 14 is a subtraction problem. We've got 10 and 3/4 minus 6 and 1/3. Again, we're going to have to do common denominators here. Common denominator here is going to be 12. Pretty simple, but maybe not quite as clear as number 5. 4 list is going to go 4, 8, 12. The 3 list is going to go 3, 6, 9, 12. And the match is, of course, at 12. So my common denominator is going to be 12. So to change 4 into 12, I'm multiplying by 3. So I'm going to multiply the top by 3 as well. That's 9. To change 3 into 12, I'm multiplying by 4. So I'm going to multiply the top by 4 as well. That's 4. And now I can go about my problem just like I did with the addition. The only difference is when I combine here, the whole numbers and the fractions, obviously I'm going to be subtracting. 10 minus 6 is 4, and 9 twelfths minus 4 twelfths is 5 twelfths. Now you could, if you wanted to, do like we did over here with number 5 and go into the idea of impropers if it looks a little better for you. Before I show you that, I want to make sure I point out, when you're doing questions 10, 11, and 12, you're going to be starting from a spot like we did right here, because these already have the common denominator. Alright, so with 10 and 9 twelfths, that's 129 over 12. 12 times 10 is 120, plus 9 is 129. With 6 and 4 twelfths, 6 times 12 is 72, plus the 4 is 76. So that's 76 twelfths. Now I'm subtracting here, so I'm going to do 129 minus 76, which is 53. And remember, the denominator stays the same, 12. Okay, so now all we have to do, finish, would be to bring this back to this. 12 goes into 53 4 times without going over, like the Price is Right. The denominator stays 12 because the denominator stays the same. Right? 4 times 12 is 48. To get to 53 leaves me 5, which is the numerator. And as you can see, once again, we've accomplished a match.